Everyone, welcome to the third of our Spring 2018 series on water and cities, green infrastructure in the era of climate change. I'm Harvey Miller, Director of the Center for Urban and Regional Analysis, or CURA, as we're known to our friends. And I want to thank our co-sponsors, the Ohio State Office of Energy and Environment and the Mid-Ohio Regional Planning Commission. They helped us organize the events this semester looking at water, cities, and green infrastructure. And as you may have noticed in recent days, that this has been a well-timed series of events. We've seen a major rain event in Columbus on Sunday. It set a record amount for that day, set in 1939 on Sunday. And if you haven't checked this out, surf the web and look at pictures from New York City yesterday, where 3 inches of rainfall in a short amount of time basically flooded many subway stops in New York City. So this issue we're facing, big rainfall events, stormwater management, this is something that cities, especially in this part of the country, are going to be dealing with in the future in the era of climate change. So it's very appropriate that we've had these events, and we're very thankful to have Bill Hunt here, who's, I would say, a world-class expert on stormwater management, low-impact development, and green infrastructure. And okay, sure. Our speaker's walking out. I offended him. No. Okay, so and help yourself, people who just came in. And also, we have a sign-up sheet here. Please, that's for professional credits, isn't it, or is it for?
Yeah.
Yeah. So we'll pass this around. If you, those of you who need professional development credits, you can sign up for this and be awarded through the Ohio Water Resources Center. Correct?
Yeah.
Did I get that right?
Thank you for announcing that.
Okay, we'll just leave this up here. You can sign up for that on the way out. Okay. Okay, Professor William F. Hunt III, or Bill to his friends, and we're all his friends now, is a William Neal Reynolds Distinguished University Professor and Extension Specialist in North Carolina State University's Department of Biological and Agricultural Engineering. He has over 100 publications on the topics of stormwater management, low-impact development, and green infrastructure. Professor Hunt holds degrees in civil engineering from North Carolina State, economics from North Carolina State, biological and agricultural engineering, also from North Carolina State, and a PhD in agricultural and biological engineering from Penn State. So really eclectic background, but it all fits together, doesn't it? Absolutely. Since 2000, Professor Hunt has assisted with the design, installation, and monitoring of over 150 stormwater control measures, including bioretention, stormwater wetlands, innovative wet ponds, green roofs, permeable pavement, water harvesting and cistern systems, and level spreaders. And he teaches roughly 20 to 25 short courses and workshops every year on stormwater design, function, and maintenance throughout North Carolina and the United States. He's an active member of the American Society of Civil Engineers, where he serves on the Urban Water Resources Research Council and the Low Impact Development Committee, and is co-chair of the Bioretention Task Committee. He was chair of the second National Low Impact Development Conference held in Wilmington, North Carolina in March 2007, and co-chaired the same conference in Philadelphia in 2011. So we're lucky to have an expert like this on a topic that's really important for the future of Columbus. And without further comments or ado, Bill, please.
Thank you very much, Harvey. It's great to see everybody here today, and Harvey told me we might fill up the room, and we have filled, particularly if the chips get a seat and the brownies get a seat. There's a lot of chips and brownies. So it's great to be here today. This is my third time onto the Ohio State campus. The first time was in 1994. I came up for a student alumni, when I was an undergraduate, student alumni meeting. That was here in 2003 to watch a football game when NC State and Phillip Rivers came into the Horseshoe, and it was a classic game with 3 overtimes. The wrong team won. From my perspective, for your different story, and it's my third time. So it's been a while, and the funny thing is that this place has really changed. It's changed a lot in the 24 years since I first came up here. So I'm talking about green infrastructure today, and ecosystem services, and how basically how a more holistic look of how well our stormwater infrastructure works is, I believe, going to change the face of how we decide to develop and how we decide to treat development. And I want everyone to get to know this fellow right here. This is a picture that was made here in Ohio, up at Old Woman Creek, on the shores of Lake Erie. His name is Ryan Winston. He's an alum of my program, and he is now on the faculty in FABE at Ohio State. And so Ryan Winston is going to be bringing, he already has brought actually, a fair amount of stormwater management to the great state of Ohio. I'm thrilled for him that he's up here already. Okay, now having done my little plug for Ryan and the FABE department, I'm going to go ahead and start talking about the main subject, which are my children, no, just kidding, ecosystem services. And though it's important for me to show my kids in them, because ecosystem services, we'll talk about that in a little bit, they absolutely pertain to people. So I'm thinking about the different types of ecosystems that are out there, and I'm doing a little travel log from North Carolina. Here's our mountains, and I was just talking to Rebecca over here. North Carolina has the highest concentration of waterfalls on the East Coast, that east of the Pacific Northwest. So if you find your way down to Asheville or our mountains, check out our waterfalls. They are wonderful. It's one of my great hobbies. Every year I take my kids to a couple of those. And then at the other end of the state, we have a large coastline, a lot of which is actually undeveloped, thankfully, because of they're part of large national seashores. And so we have tidal marsh ecosystems. And then you have some that are behind the house. And these are the types I know you can relate to here, okay? Ecosystems, the urban creek right behind it. But a lot of people wouldn't think of a parking lot ever being an ecosystem that you might enjoy. And my kids, about the 3-inch rain, we were slated to get a big rain. It did not quite materialize. We didn't get the 3 inches that we thought that you guys got. We didn't get an inch, but my daughter, one of them, this one, she was like, "Daddy, if it rains, can we please go outside and play in it?" And that's when you know you've succeeded as a parent, okay, at least in my field. We treat runoff, and there's a lot of reasons to treat runoff, and we'll go through those things, all right, in just a little bit. But we treat runoff with systems that, while they're small, are also little baby ecosystems, okay? And you'll see why that is important as we progress through here. Now, what exactly is an ecosystem service? Ecosystem services are precisely, you can read it, though I'm going to read it, I'm going to say it, the benefits that we get, that people get from ecosystems, all right? And here's a list of some of these, like, I can't read that. Well, maybe this will help you read some, and here's some more. And the point is that all of these services or benefits have value. And on one of the things that I appreciate, however reading that, I have a degree in economics, and I'm not an economist. I'm not. I'm an engineer. I'm sorry, I'm an engineer. But economics is a very, very important part of what we do in the development world, and even in the design and selection of different types of stormwater control measure world. All right, and this actually gives me great hope for the future, because all of these things have value. That means they're worth something, and that means the potential for monetization exists. Okay, and then as soon as you can start deriving monetary benefits, people who actually make these decisions, and they're called developers, all right, might actually start doing what I consider to be the right thing, or the more holistic choice. So when we take a look at green infrastructure and ecosystem services, there's a whole bunch of ecosystem services that are out there. There's two main ones, and I could also throw in sediment control, so maybe 3, that we design our green infrastructure, green stormwater infrastructure for. We worry about water, okay, like hydrology. We worry about pollutants, water treatment. Those are the two biggies. And we will talk about those two biggies certainly as a part of this presentation. However, because a lot of these systems are vegetated, they have the ability to offer a bunch of other services. And this is what I'm talking about, the value associated with carbon sequestration, or the value associated with cooling a city down or neighborhoods down because you're using vegetated stormwater treatment that heretofore may not have been used. Those things have value. And the question is at what point will these other dashes under this other societal benefits start impacting the decisions that are made about whether or the type of practice that you're using to treat your stormwater. So let's talk about the 2 to 3 basic things that we want our stormwater green infrastructure to do, all right? No matter where we go, if I enjoyed the roundtable earlier today, Harvey. I had the opportunity to go a fair number of places. That's the first time I've had that right off the bat. And it kind of got the blood flowing. It was great. So I really, hopefully the people that came liked it too, but I thought it was good. And so wherever I go across the globe, wherever you go across the globe, this is one of the things that people worry about. I was just telling the roundtable earlier, almost a month ago, 5.5 weeks ago, I was in Jordan. They don't get much rain in Jordan. And they took me to it, but the first thing they wanted to take me to was a place in the country, in a place called Ajloon, that gets flooded. All right? So no matter, they said, we got a problem with flooding. Now, Jens, you're from Denmark, right? They've had big flooding problems in Copenhagen, and people there, we talked about New York City yesterday, no matter where you go, Beijing, people are worried about getting flooded, all right? So we're going to put stormwater practices in to help treat that. And another issue that we worry about is that engineers are really good at collecting the water and then releasing it in a, quote, a very efficient manner. And what efficient manner means is that we let that water rip. We get it to a point that says, see you later, and away it goes, okay? Well, that may be fine and dandy if everything in your world is concrete line. But at some point that water does find some place that is no longer concrete line. And then once that happens, you get this. I'm a believer in sustainability, including sustainable property. Because that is what's being lost here because we let that water rip. And it's this erosion, and to be true, this person had to move because of, honestly, the sins of the upstream. And that is something that really bothers me as a design professional, that we have standards and have allowed stuff like this to happen, where people upstream can really mess up life for people downstream. And so we are just trying to design practices to keep this and this from happening. Let's talk about how that can be done. I mentioned this a little bit earlier today. This is a site in Raleigh, North Carolina, okay? Home of the Wolf Pack, which is, you know, your sister's school in Raleigh, in North Carolina. And we had this is a wooded patch, and this was, well, this is exactly what it is. This is a commercial site. And this wooded patch was there, and the developer came and approached the city council and said, hey, we'd like to develop this. And the city council was like, I don't think so. It's woods, it's in Raleigh, you don't have much of that left. And so the developer said, come on, please, or however that's said. And the city said, all right, if you can deliver me a low impact development, we'll let you put it in. And so you might be saying, okay, what is a low impact development? Well, low impact development comes back to this idea of the hydrologic cycle and what would happen on the property before development occurred. How much runoff will we get? How much evapotranspiration are we getting? How much water is leaving infiltration? Does anyone have an idea, cumulatively, over the course of a decade, how much water might run off a wood patch? 5 to 10%. And the survey says you are right, okay? 5%. So the developer wants to take this patch of woods, basically knock down 90% of the trees, and then put up a commercial site. And it's a he in this case, has the opportunity to say, all right, I'll do that, or turn around and walk. I'm not going to do that. I can't do it. All right. One of the things you're going to hear about, I can't. It's too hard. I can't do it. Right. Well, the developer, this is a pretty valuable piece of property. The developer's like, all right, I'll do it. Okay. Economics spoke. He hired an engineer. Engineer designed it, and then this is the key part. State of North Carolina, or the city of Raleigh says you have to monitor this site to make sure that you actually designed and delivered a low impact development, which basically meant that 5% runoff. And that's where NC State comes into the equation. So we were hired They got a grant, to be fair. They got a grant from the state of North Carolina to make sure that this development actually, and so you can imagine what I refer to as the pucker factor, you know, when the designer's like, oh, NC State's coming. Imagine if Ohio State's gonna be mounted, oh, they're coming. We're gonna have to do a really good job. And so we monitor to see how they did, all right? And this is what the designer put in. And of course, the obligatory green stuff on the surface, swales, bioretention cells. They had a big rainwater harvesting system, which they used to flush the toilets and the Whole Foods, and then to do irrigation, other things. And then they had a big workhorse of it was this massive underground detention facility with an infiltration gallery. And NC State's job was to monitor everything that left this site right here, and then we also monitored what left this standard commercial site over here to see how close these guys got to a true low impact development. And here we go. We're going to start at the top. This is the conventional site below. And I'm going to talk about the runoff coefficient. The runoff coefficient simply is you have all this rain over the course of a year, how much of it runs off. For those of you that are familiar engineers with the rational coefficient, is different from that. Okay? This is cumulatively how much of the water that fell onto my watershed ran off. And you can see that our site, the conventional site with the dry pond and some swales, 1 out of 2 drops ran off. And that was absolutely in line with other studies that have been conducted along the east coast of the United States. And then our LID site, that little sliver, that would be 1 out of 50 drops is actually finding its way off the property, which, by the way, compared favorably to all the other studies that had been done at that time in the eastern United States. And by the way, 2%, not that you guys don't know this, is less than 5%. So they actually had met this level, and people are like, how in the world did you, quote, beat Mother Nature? Well, Mother Nature does not have about 2 foot of driving, 6 feet or 2 meters, about 6 foot of driving net. Because these big, darn it, those big concrete chambers I showed you that were tied into the infiltration gallery, they were putting 6 foot of pressure on the soil, essentially pushing water into the ground. And trust me, we don't want 6 foot of driving head where we live. Because we wouldn't, most of us, unless you played basketball, wouldn't be able to breathe. Okay? So that's why this site actually did a little bit better than Mother Nature. Needless to say, it got built. All right? And I pointed out earlier, it was the developer's decision. He could have walked if it were not the economical choice, not economical sense. But it made sense for him economically to do that. All right? Keep the next one. Let's talk about, and I'm going to refer back to this a couple times in this presentation. But, so I took one big site and did something. But now let's say you're City of Columbus, and you are revitalizing an urban district. And Harvey was showing me some of this before, what's going on in the skis. What's that band?
Oh, Franklinton?
Franklinton, that sounds good. I can say that. That's good. I can pronounce that. Franklinton. All right. What's the name of the river? Scioto?
Scioto.
That was close. Okay, so the city likes to operate in land it owns. Just does. Likes to operate in land it owns. So that's like the butt width of a road. Well, what if you had this opportunity to, and they also, know what cities like? They like trees. And by the way, there's a lot of good reasons to like trees. And my job is, and I almost I could do a tree lecture. Actually, I can. If I spent some time boning up on it, I could. But I could do a whole lecture on just the beauty of trees. But let it be understood that trees add a lot to an urban environment, okay? Here's some examples. This is the closest thing I had to the Midwest. So I had a picture from Clinton, Iowa, all right? But the idea of something called a silva cell going underground that you would put media in. As a matter of fact, let's see if this video works. You might, yeah, okay, good. By the way, you get the siren for free. The idea is you have this deck and post system, all right, that you fill up with a special soil, if you so choose to have a special soil, that the plant roots will grow in and around. Because if you ever talk to any urban forester, they're going to tell you that the typical way we plant trees in the city is dooming these things to very short lives. Because the roots have to be really strong. Think about how compacted the soil is in anywhere USA, anywhere developed world, all right? Very hard to push the roots in. So here you have really loose soil, you put a tree nearby, like on the edge, the tree grows in amongst this nice soil, and the reason I have this decompose system is you can build stuff on it, all right, and put over it, and you can drive vehicles on it, park vehicles. Basically, you don't lose any space. So all this is able to go under a street, or in this case, part of a street and then into a sidewalk area. Okay. And by the way, they did this massive thing in Wilmington, and they planted a crepe myrtle. After all of that effort, you just put a crepe myrtle in, for real, for real. But the reason was there was an overhead line, and the city felt comfortable with that. So anyway, you have this ability to do work in this beltway that the city owns, all right? And you can put a tree in, you put trees in, and this is essentially what it did. If you take a look, all the rain, all the runoff, about 80% of the water that flowed along, let me go back to this picture here. Ah, darn it. Okay, good, this will work. Water that's flown along the curb line is directed over here. You don't see that, I apologize, but it's directed here into this system, all right? There's a manifold essentially that delivers water along the length of this system. The water soaks in through that media, all right? And we found that with this particular design that 80% of all the water that flowed along the street found its way into our stormwater treating street tree system, all right? And potentially got cleaned. I actually don't show you the water quality data in this presentation. You have to trust me, it did a great job of getting clean. But one of the big things it did is because the water was flowing through a media, the media really regulated or metered the flow out, all right? And as such, what was coming in versus what left, our street tree system was actually helping with hydrology, all right? Let alone the water quality improvement that it ended up providing. How about blue roofs and green roofs? Okay, you guys have a team called the Blue Jackets. Maybe they should think about putting a blue roof on their team headquarters. All right, well, what's the difference between a blue roof and a green roof? Well, a green roof is what we might guess, it's got plants going on. A blue roof does not. A blue roof in this particular case just has gravel, and it's designed to capture water on the roof and then slowly leak it out. And we did some studies looking at the two of them. And what's nice about it is the color scheme for blue roofs and green roofs and charts is just handed to you like on a platter, okay? So you got your blue roof, you got your green roof, and the control roof is the gray one. And this shows you how much runoff we had from the blue roofs and the green roofs. Now think about it, where are you gonna use one of these things? In a place you got no room to do something else, right? Because the land is so expensive, you can't really afford anything else. So you have them do this, and what we found is that from a runoff perspective, blue roofs did a really good job, like green roofs, of reducing cumulative loads, all right? And to a lesser extent, it mitigated peak flows. It was not as good. They don't provide as big a, if it's a big enough storm, they don't do a great job of mitigating peak flows. But cumulatively, their main benefit is that they reduce the volume of water it's leaving over the course of time. All right, so there we go. So we've talked about the water part of what we want our green infrastructure to provide. Now let's start talking about nutrients and pollutants. This is a picture of, we call it nutrient abuse, all right? And you see a whole bunch of algae growing. Now, one of the practices that we have in our toolkit in green infrastructure is something called a constructed stormwater wetland. And a constructed stormwater wetland is modeled on what type of landscape? What do you guys think? This is not meant to be a challenge.
Wetland.
Oh, wetland, that's exactly right, okay? So one of the things as an ecological engineer, where's my ecological engineer? I got a few of you guys here, okay? Like, don't be ashamed, it's fun. It's like, it's a great field, okay? But as an ecological engineer, engineers like templates. We like templates to do things. Like, you're not very imaginative. You're always using it, okay, fine, we're using a template. But in ecological engineer, our template for a constructed wetland is a naturally occurring wetland. All right, so we built constructed wetlands. We have a whole bunch of them that we've built through NC State that we've monitored across North Carolina. And we had this opportunity to start comparing data from our human-designed, human-built constructed wetlands and compared all of them to a naturally occurring wetland, a reference wetland, that was in eastern North Carolina, just to see if our human-built wetlands were essentially getting us kind of close to what a naturally occurring wetland was doing in our great state? And the answer was, yeah, it was getting us kind of close, all right? In fact, the median organic nitrogen concentration leading the two was extremely similar. By the way, the black plus lines, that's the naturally occurring wetland. All those other symbols are from the 7 constructed wetlands that we built to treat stormwater runoff. And so you can see that almost all of them were doing a great job of mitigating or metering nitrogen concentrations. Now people are like, well, might want to eliminate nitrogen concentration. That's not normal because they're nutrients for a reason, so some amount should be there. And so our constructed wetlands are doing a fine job. Now how many of y'all are pessimists in the room? Thank you, I appreciate your admitting it. And you probably immediately were like, what's happening here? There's something wrong with this. No, there's nothing wrong with this data. That site was like a fifth the size it was supposed to be. Okay? So this is important for the, for the designers in the room. There are design standards for a reason, right? You just don't slap it up, oh, we got it, man, we're good. No, there's actually design steps you need to follow to make sure they are sufficiently big. Now, I don't know if the North Carolina design, in fact, I would hazard a guess that the North Carolina design is actually bigger than it needs to be, but I can tell you it's not 5 times bigger than it needs to be based upon, for example, these data right here, okay? All right, now let's talk, back to blue roofs and green roofs, since I'm having so much fun with that one. So check this out. This is the nitrogen load, the green roof nitrogen load, and then the blue and the control. And then what do you see there? Now every once in a while you'll meet a sort of a green roof proponent and they're like, oof, oof. They're shocked. My God, shocking. Actually, I had that said after one of my talks about green roofs, when I started showing all the nutrient loss from a green roof. And I swear to you, the woman got up after me, the moderator, and she says, that was a shocking presentation. I'm like, okay, it's just the data. Just here to report the data, man, just the facts, okay? But a green roof, and you have any idea why the green roof might have such a high load loss? Because the people who make the green roof media are trying to get their plants to take. It's chock full of stuff that honestly, you don't really want up there because the water's going to leach that stuff out, right? The blue roof, on the other hand, was right in line with the control roof. And then from a phosphorus perspective, it was also like bad, all right? Now, I'm not here to just throw out green roofs and tell you that they're crappy. I'm not here to tell you that. In fact, they provide a lot of other ecosystem services, and I'll touch on one of them towards the end of my presentation. But do understand that just because a practice is good at some things doesn't mean it's going to be your silver bullet across the board. And by the way, if you don't care about nitrogen and phosphorus, it doesn't really matter. The green roof, in that you can afford to have a green roof that discharges excess. If you really do not care, because it does a lot of other things for you. All right, but if you really do care about nitrogen and phosphorus, which by the way, we do in North Carolina for a good chunk of it, then they're, maybe this blue roof is not a bad option because guess what it is? In addition to being better at nitrogen and phosphorus discharge, it's also cheaper. Okay. Okay. Now, I'm bringing it home for you. Of course, this is not Columbus, but this is what I call one of the most epic fails in the history of development. And it's our river caught on fire. I don't say our, it's our river. It caught on fire. And also, to me, that's an embarrassment that happened in this country. But I've got good news for you. It's not on fire anymore. Like, it's pretty nice. We did some work up in Columbus. I said, this is pretty nice up here. And to be fair, this triggered a lot of good point source work, and we did, the river's cleaner, a lot, Lake Erie got a lot nicer. We have similar success in North Carolina, Chihuahua River's a lot nicer. But it's not like we broke through and have some pristine thing. You know why? Because we did not do a good job of treating the non-point source pollution, all right? So let's talk about pathogens. Pathid Desert, if you come to North Carolina, we encourage you to do that. Spend your money at our, for example, our beaches. All right? This is not North Carolina, but we have the exact same signs. I'm just trying to spread the love. This happens to be in New Zealand. And they have to put a sign that says, hey guys, don't play here because it's polluted. And I'm going to tell you something. I've collected data from a similar discharge point on North Carolina beach, and I'm going to tell you right now, it is really polluted. Like, it's really bad. Like, the pathogen counts are scary bad. All right? And so they have to put a sign that says, don't play here. Well, guess what kids do? Kids have a choice. They can either play in this grand ocean, this magnificent ocean of ours, or they can play in the little stormwater rivulet. What do you think they're picking? The latter. Right, the boys forget the ocean. I'm playing in that because it's not to do this. So we want our green infrastructure, obviously, to kind of address that the best we can. So here's a picture of Charlotte. We were talking about Charlotte earlier, the bioretention cell in downtown Charlotte. And this is what it looks like. And you don't have to be a research scientist. You guys remember Lucky Charms? I'm some older guys. Do you still eat Lucky Charms? Lucky Charms? You stopped eating, man.
I remember them.
You remember them? I think this lady back goes, I don't eat those anymore. I said, it's good. I mean, I don't either. But I do give it to my, so this is the blue diamond versus the green squares, right? Blue diamonds are inflow concentrations, green squares are outflow concentrations. Well, which one's better? Well, let me try again. Can you tell that the bioretention cell cleaned the water? If blue is in, green's out? Yeah, absolutely, it did. We clean it almost all the time, not all the time, but almost all the time. That's what we want our green infrastructure to be able to do. Here's another example. A colleague of mine at the University of Maryland, Dr. Alan Davis, great guy, great researcher. And did this study looking at what happened to all the metals that came in, zinc, copper, lead, cadmium. And this is, of all the metal that came into those sites, he shows you the fate of them, all right? And everything that's in green, that is caught by the media. That little, I don't know what that color is, red. First of all, men only know about 10 colors. Just in case, I mean, we know, most of us know about 10 colors. You get 8 colors in the Crayola box, plus pink and plus white. That's it. That's what we got, all right? Now, I know for a fact that my wife knows about 8,000 different colors. And I think she told me that that's called magenta. I don't know. But that little sliver right there, that's the amount of pollutant that got translocated to the tissue of the vegetation. And then the blue sliver, which is a little bit bigger, is what left. All right? So do our bioretention treatment devices do a good job of sequestering metals? Absolutely. Okay? So think about these different pollutants. They're doing a good job. And here's the thing. What I just shared with you is exactly what we expect our green infrastructure to do. You know why? Because that's what it's designed for. We're designing it to mitigate flows. We're designing it to trap metals, take out pathogens, regulate nutrient discharge. So the fact I just shared all that quote success with you, honestly, if it wasn't being successful, we are therefore falling down on our jobs because that's what that stuff is designed to do. Let's talk about other things. Let's talk about other things. Because this is the future of stormwater management. For example, let's deal with climate change. All right? I'll let you guess which president issued this executive order. But in this executive order, he mentioned stormwater and he mentioned greenhouse gas emissions. Now, I went to my Department of Transportation colleague and said, Matt, who by the way, Matt is an OSU alum. He swam for the Buckeyes. I said, Matt, you'll be proud of him. I said, we need, because I've been driving all over North Carolina as part of my extension responsibilities, going from city to city. There's a lot of vegetation in your stormwater treatment. And I know it's sequestering carbon. Don't you want to account for that? And after about a year of me beating that drum, he finally, cried uncle and said, fine. How much? I said, $80,000. It's cheap. And actually, that was cheap. And he's like, okay, you'll do it. And so we looked at carbon sequestration rates. And yeah, like swales, little strips, they sequester carbon. You're able to, in fact, this is an interesting thing. We started comparing standard swales to wetland swales because, like northern Ohio, it's pretty flat. Right? And the water level's kind of near the surface sometimes, and sometimes your swale you can mow, and sometimes it's got wetland plants. The DOT, it's got reactions that hate those wetland plants. Like, oh, they want to get rid of them. And I said, I bet you those wetland swales, if we just let them be a little bit, I bet you they sequester more carbon than your standard swales. Well, we tested that, and there's your wetland swale. And the answer to that one was, yeah. All right? So then, Matt was like, you know what? In addition to sequestering more carbon, ready for this one? They're cheaper to maintain. Because you don't have to do a wetland swale? You don't have to mow it. You don't have to mow it. And Matt is a sharp dude, and he spat out X number of dollars they're spending per year on mowing our interstates and our US highways. He's like, You know, I might be able to save like 1/10 that cost by allowing certain of these things to become one. He says, you know what? Let's just speed up the process. And so they actually started installing real simple check dams to wetlandify our swales under the guise of making more carbon to be sequestered, getting more carbon sequestered. I think it was the first time in the American South that a decision on a stormwater practice was based on carbon sequestration. We've kind of let that be on the down low. Okay, don't tell anyone. Our legislature's like, you can't even talk about that, let alone make a decision about it. Okay, so another thing I want you guys to know about where are we going. You can calculate carbon footprints for any type of stormwater control measure you want. And it's based on 4 things. The stuff that you put in it, the construction of it, the maintenance of it, and all of these are like bad, bad, bad. And then the vegetated systems allow you to sequester carbon. And so the calculation is the following, all right? You can start calculating carbon footprints. And it's been fascinating to see that certain facilities, certain types of practices do better than others. In fact, this is using North Carolina design standards. And for the record, this graph is wrong. I do not know why I continue to not fix it, okay? But I continue to not fix it. But this filter strip level spreader thing should also be south of the 0 line. And depending on how you plant it and design it, you have certain practices that can actually be carbon sinks, which then might allow you to sell this stuff on the market. I don't know about you, but I think that's awesome, all right? Certainly it can impact how we design our systems. And I even have a startup company that borrowed our stuff and created this model that they then are trying to sell. I think they've sold it in Canada, which kind of makes sense because they still care. And of all the carbon that is produced, 33% of it with this base design essentially was sequestered. All right? So that's potential benefit number 1. Let's talk about the heat island. All right? We all know, and it's a big deal in Chicago. If I was talking with Harvey earlier, and he talked about how Chicago and Columbus are the 2 places in the Midwest that have the best economies, okay? Well, I think about Chicago, and I think like every 3rd year, you hear about heat stress deaths, okay? And it's because it's a big urban heat island. And one of the things you can do, and just look at this picture, is you can, ready for this, to come as a shock to everyone, put trees in there, okay? And a study at the University of Tennessee found out that if you can have a certain amount of trees, and I don't know the exact threshold, but they measured it in Knoxville, that they found that the summertime overnight temperature, in the worst case, was 4 degrees cooler in places that were near trees versus those that didn't have any trees nearby. Now, 4 degrees Fahrenheit, I should say. 4 degrees Fahrenheit may seem like a big deal to you, because I bet you every one of you has the possibility of air conditioning. But not everyone has that, right? And a 4-degree overnight difference in temperature can make a big difference in how well you sleep at night. All right? It might make a difference in your health. Speaking of, there was a study done in Toronto that showed the fraction of canopy coverage in Toronto and the number of emergency room calls due to heat stress. All right? And check this out. As soon as you got to a 10% threshold of tree canopy coverage in a city, the fraction of heat stress calls dropped precipitously. Now remember I showed you the picture of the stormwater treating street tree that had all that soil that was growing in. They put a little crepe myrtle in, all right? But you could put a different tree if you wanted. Do you see another benefit to that tree now? And is this not a value? A monetizable value? All right? Now when we're designing our stormwater treating street trees, I'm not factoring this benefit in. But there is real value associated with it. Okay. Now, you're going to hear this thing, if you haven't heard already, called green streets. And it's not hard to think about what it is from a stormwater perspective. It's green infrastructure applied to streets. Okay. So, part of having a green street is you get out and you walk it. They want you to walk it, all right? And if you're walking it, that means you are close to the tailpipe of a number of vehicles, which means you are certainly exposing yourself to particulates. all right? Now, none of these pictures are in the United States, so don't feel like, oh my God, that looks awful. It is actually awful. Fortunately, our cities aren't quite this bad, but it is still something to think about. So a colleague of mine at the University of Surrey, which is south of London, did a study where he compared basically the particulate exposure of people walking on a path next to a road that had shrubbery. Okay, again, thinking about, I talked about cities doing things in along streets, all right? So now the idea of putting vegetation in along the street to treat stormwater runoff, does it also have the potential benefit of shielding people from particulate matter, okay? So he looked at wind blowing this way, wind blowing this way, and wind blowing this way, right? Because the cars are here, the people are here. And then he said, okay, what happens if there's no vegetation? What's the particulate exposure? What if you're standing in front of a tree? What's the particulate exposure? What if you're a monkey and you're in the tree? And then what is this here, shielded by the tree? And he found out, remember 3 and 4. 4 is the one you really want to worry about. 1 and 2, either no protection or you're standing in the wrong place. In all 3 wind patterns, it was a lot better to have that green / vegetation there between you and the vehicle. All right, you know who doesn't think about this when we design stormwater treating street trees or any sort of bioretention cell along the street? It would be the stormwater engineer. We're not thinking about that. And yet there is real benefit to having that there in terms of keeping people safe, all right, or at least a little healthier. Now let's talk about biodiversity, another sort of human health thing to consider. We looked at ponds with wetland features, ponds without wetland features, and we found that ponds without any wetland features had and importantly, a significantly lower likelihood of having predators. Now, you might be thinking, North Carolina, predators, he must be talking about alligators and alligator snapping turtles. No. I'm talking about things that like to prey upon mosquitoes, okay? So now all of a sudden, you can start designing facilities like wet ponds using ecosystem services effectively to protect people, all right? To keep these facilities from being mosquito breeding grounds by basically building things that you know predators like to hang out in, so they'll prey upon the mosquito population. It's pretty awesome, right? And even we as ecological engineers honestly have been doing this one for a little while. Other types of ecosystem services. There are cultural services that are provided. This is in Singapore. It is a massive thing called a biotope. And what they do is they pump water from a little river, big creek, into this, and they clean the water before they discharge it back into the creek. But you see what they've done in addition? There's a lot of walkways in around. They've made it a recreational amenity. Here's one in Wilmington, along near the coast, a recreational amenity. Here's a situation that the city of Atlanta had. The city of Atlanta had the choice of taking runoff from their 4th ward and sticking it in a pipe, or they could instead put it into an above-ground constructed pond wetland thingy that supplied ecosystem services such as recreational services and even educational services, all right, such as this is where the 100-year storm's going to be, all right? The EPA gave them essentially a choice. They had to do something. It was a CSO. They had to do something. You can guess which one they picked, all right? So check this one out. You'll see as I advance through these slides, there you can see the pond being constructed, and I want you to just take a look at the earthwork that's going on in and around our pond site, okay? This is the pond wetland right here. And there's the pond in the wetland, here's some parkland associated with it, and now I'm just going to show you other things that got built as a result of the stormwater infrastructure, okay? So the city of Atlanta made an investment. I want to say it was a hundreds of million-dollar investment. I don't know if it was quite to the billion-dollar threshold to build this park, okay? And I will tell you, they picked a part of town that was somewhat derelict, all right? They built this, and then all of a sudden, the private money followed, and after the city of Atlanta made their stormwater investment in this area to basically uplift it, to beautify it, $500 million private dollars followed. Now, you know what? I don't know about y'all when you took your hydrology class, urban hydrology, but at NC State when I took mine in 1993, and 25 years, oh my God, 25 years ago, Dr. Malcolm, God rest his soul, never mentioned the possibility of community uplift as a possible outcome with my stormwater device. All right, but the reality is that's exactly what happened, and I think it's amazing. Seattle, I talked about this a little bit earlier today. The Seattle C streets. They took big fat streets. Oh, I don't show it. They took big fat streets and they turned them into. Darn it. They took them into skinny streets. They changed the value of the properties. Looking at, they increased the value, property's value by about 5%. By introducing stormwater controls in along the street because it looked nice. And then there's this case from Baltimore where they had the Montgomery Ward warehouse and it was shaped like a big U. And trains, you see what's right here? Trains would come in under this shed and before it was a green roof and they would load their product up and send that out across the East Coast. All right? Well, Montgomery Ward sold this building to a developer. And the developer agreed to have a green roof put onto his roof. And it was a he, because I spoke to him. And I was with him, I didn't. Okay, I did speak to him, but I was me and a whole bunch of other people. So, he was saying, he says, you know, I was a little uncomfortable about putting a green roof up here, because, you know, it costs extra. He says, but here's the thing. When you build a building, and you're renting spaces out, office space out, you basically make money by renting all of your office space, right? Leasing all your office space. Well, in his plan, he assumed that the outer-facing offices that looked onto Camden Yards and Inner Harbor and whatnot would have a certain rate of uptake, and then the inner ones would have a lower rate of uptake. In fact, he assumed it would take 3 years for all of those inner offices to be rented. It took 9 months. You know why? Because instead of looking on some dilapidated roof, they were looking onto a green roof. And people wanted to be associated with that. He said he got his investment back in like 3 months. All right? This is when the economics are beginning to dictate the right thing. All right? Here is in Sweden. Can you tell what they use their dry detention facilities for? Those would be soccer pitches. All right? Permeable pavement has an advantage. You can park on it. That is a benefit. I don't call it ecosystem service. I don't call, maybe ecosystem service is a bit of a push, but you get to park on it. Rainwater harvesting, well, you've got a lot of, you can replace potable uses. In fact, in California, they take this runoff from the library and then they use it for the urinals and they let you know about it. And peeing is an ecosystem service, I think. Check this one out. Constructed wetlands, this is one I was associated with. It's in the mountains of North Carolina. We put it in to help protect, honestly, the hydrology of a trout stream, okay? Well, we went up to go visit it one day, and we met the local stormwater administrator. He says, yeah, we love this thing. I said, oh, good. I mean, is it doing its job? And he says, I have no idea if it's helping with the creek. I said, why do you love it? And he says, because it seems like every bride who gets married is coming down to this wetland to have her picture made, all right, because of all the flowers. And this bouquet of flowers was picked from that wetland. It is a beautiful spot in downtown Newland, and I know that cut flowers is a market. There's my daughter, she's like, she wanted a flower, I got it for her. Think about taking your constructed wetland or your pond or something and actually selling flowers from it. We're doing that with floating islands. Take a pond, we put these floating islands on there and set them up that you can harvest the plants. There is a market. You can make money from doing the right thing in stormwater. Back to my green roof experience. This is in Vancouver, BC. It is the Fairmont Hotel. And according to them, they save $30,000 a year by being able to harvest their herbs from their ingredients for their restaurant from their roof. I'm like, oh, that's nice. That's nice. But I told you guys a little bit earlier, I happen to be a believer in capitalism, at least controlled capitalism. And here's the market speaking. The market would say, oh, fine, you can say that all you want. All right, that's a nice, you're marketing, oh, we did it, blah, blah. But the reality is that they built they had an opportunity to upgrade their hotel in Toronto, and when they did that, they added a green roof to it too. Entities that make money don't throw good money after bad. All right? An ecosystem service of food provisioning from a stormwater control measure. Who'd have thunk? All right? And so just think about all of these other benefits that are out there that heretofore we do not really account for. We focus on water quality, we focus on hydrology, and that's where our story ends. And when you start adding a lot of the aesthetics, recreational, educational benefits, those increase property values. Again, I never thought about that. I didn't learn that when I was in school, but the fact is if you do these things right, they increase property values. And so to me, this, I feel like it's a very positive, obviously it's a very positive story, that we're on the cusp of being able to do the right thing almost all the time. It's because the market is beginning to catch up with this understanding that, hey, you put this thing in there to clean, to remove zinc, reduce flooding, but you can also harvest flowers from it and sell them. Or you're sequestering carbon, put that on the market. Or the government says or the developer's like, I want to have a green community. I want to say I've got carbon neutral stormwater. Now all of a sudden, these practices, you see them in an entirely new light. And here's the beautiful thing, is if you start accounting holistically for all of the benefits or the dividends that our investment gives you, we win. It can all be people-centric if you want. We win. But guess who's winning with us? Our ecosystems, our environment, because we are doing the right thing. So with that, I'm happy to open up questions about ecosystem services, NC State's football schedule next year, whatever you want to chit-chat about. I know I have a few minutes left. And again, I want to thank Harvey for inviting me. It's been a real pleasure to be up here so far. And it's great being here in Columbus. All right, so what we got? We have time. We have about 6 minutes for questions. Don't leave y'all much.
You can go a little over.
Okay,
You can
cool.
leave if they want, but
Okay.
questions.
Your
I'll get you next.
bioretention systems,
Yes, sir.
what's the metrics for the CO2 retention? I mean, do you measure the roots in the plants, or just the roots, or how's that work?
Yeah, the way that one has been calculated, to be fair, I have not, that's not one of the ones that we've looked at. But when we look at the other systems, we look at recalcitrant carbon in the soil.
So
So it is the roots.
It's the roots.
Yes, it's the roots.
I mean, the plant growing on top doesn't matter? I mean, it's got carbon in it.
It does, but because the carbon has to stay sequestered, I think for 100 years for it to count,
Is it time?
you can't rely on the plant. But it does have carbon in it, so. Yeah, go ahead.
What about all the bacteria in the soil that helps the roots grow? Is that part of the CO2? They're made out of carbon too.
They are. I'm trying to think about how the measurements are made. The way the measurements, because basically what's done, I'm going to start with saying I don't know. I don't think so, but I think sometimes you say I don't know. I don't know. I don't think they are, but I can look that up. I know how we did it, is we harvested it and then we burned things off. And so I guess if the microbes the mass would be detectable after it was cooked, or the loss of mass would be detectable when it's cooked, then the microbes would.
It's how you measure it.
Yeah, that's right. Good questions. Yes.
So I think you have shown a lot of data on like how many ecosystem services that these green infrastructures provide. So for most of those data, are they coming from like real observation or like from models that you can use?
Most of it is from real observation. But this is actually a question that was asked a little earlier during the seminar. There is certainly a role for models to help take what end up being essentially case studies, a whole bunch of them, but case studies, and taking that and being able to project out under different development scenarios. And one of the things that was asked earlier is there a role for models? And the answer is absolutely, absolutely. The models, we need to have models that are better at designing systems. We have a lot of planning level models that are out there. But certainly from a system design perspective, we could use a lot more help in the model. And that's one of the reasons I'm excited about that one model called Carbon Storm, is it does help designers basically adjust their design so that they optimize or maximize, whatever word you want to use, carbon sequestration, for example. But there's a lot of modeling opportunities out there. Yeah. Yes, ma'am.
Has river restoration been considered to be a green infrastructure?
Yeah, that's a good question. It's a battle. So the question is, if you do a stream restoration, should that be considered green infrastructure? And, you know, either you bring it in under that, or you just have its own category and say, are there ecosystem services that river restoration provides? I think most people would agree the answer to that is, yeah, absolutely. Even straight up recreation, sediment loss improvement, cooling of streams. You know, a good stream restoration might make a creek that was not fishable now fishable. You know, after 5-10 years time passage. And so certainly ecosystem services are associated with river or stream restoration. And so I think right now, the way things are divided up in the EPA world is that, well, I shouldn't speak for EPA. Let me say for DEQ, they would be treated as two different things that are complementary, but they are complementary, which means maybe they do fall under the same, you know, the same larger. They do fall under the same larger umbrella. But right now, people tend not to consider stream restoration as a stormwater, as a green stormwater practice. Okay. But it doesn't mean that they're not providing a lot of good.
Yeah.
Good question.
I just wonder if you had any, I don't want to sort of dampen things here, but just cautionary tales in terms of trade-offs. So I saw briefly about, you know, food provisioning and whether that's ideal with places where you're concentrating metals, or
Sure.
if you are beautifying an area and bringing more people out onto the street but don't have the street trees to block particulate matter. Is that like things,
Right.
trade-offs like that?
Right, those are certain, and one of the things, and I should have probably done an even better job of doing this, but remember I told you about the green roofs weren't really good at nitrogen and phosphorus. It's important to note that not every practice delivers all those ecosystem services. Certain practices are absolutely better. Constructed wetlands, they're like really good, right? They're also the most densely vegetated. Bioretention cells are also like good, really good at supplying ecosystem services. But do note that not every practice is good. And for example, here's a cautionary tale. A bioretention cell that is very densely planted will do a better job of a number of things, including carbon sequestration. Okay? It is more likely to stay permeable, all right, and have better infiltration throughout. However, we put bioretention cells in urbanized areas, often in parking lots. And a densely vegetated bioretention cell in a parking lot in North Carolina has two major drawbacks from a safety standpoint. And one is driving in lines of sight. And number two is dudes or dudines can live in there. All right. Now, if they're just living in there and not making a ruckus, okay, no big deal. But people can hide in this and jump out and attack folks. And so, when you design a bioretention cell, we're going to be pretty careful. In fact, our design guides in North Carolina is very explicit. We do not want them overly, you know, overplanted. The state of North Carolina actually has, after 5 years, we want 50% canopy coverage. That's it. And that's the idea of driving a little less densely planted. But in Singapore, they do not care. Because, and have you ever been to Singapore, when you get off the plane there, they have a sign, like you're walking down the jet bridge or whatever, and they're like, if you have drugs, you might be killed, okay? And I mean, they're serious. Like, you can, if you are trafficking drugs in Singapore, you are you are subject to capital punishment. Okay, so they don't really have crime there. I mean, that's just a good example, but they don't really have crime. It's like the one place where, like, yeah, my daughter was 18, so I want to go out at 2 o'clock in the morning. I wouldn't be happy about that, just period. But like, okay, Singapore is the place I'm okay with that. All right. in that regard, they don't care how much grows up, and they have really, and by the way, it also rains 80 inches a year there, so they have really densely vegetated bioretention systems. So do understand there are a lot of trade-offs, and it's not, you're not dampening things. And in fact, I'm glad you asked, because everyone needs to know that you typically cannot have one practice that does everything you want without potentially causing, like for example, a wetland, any practice is really good at catching trash. All right, and that's great. Accumulates it, and it looks like who did it and ran. And then your property values go from looking good to like, oh man, that's an eyesore, there's all the trash there. And so coupled with the use of a constructed stormwater, or any stormwater practice, you gotta have maintenance that follows up, even if it's just trash collection. You gotta have that. And so there's a lot of things sort of above and beyond just planning, installing, and saying, we did it! That enables these landscapes, for example, to be, to retain a higher value, and maintenance certainly is a big one. So I'm glad you brought that up.
One last question.
So in Columbus, we kind of have a problem convincing developers to implement GSI practices. And I think that like Karen's stick has been the stormwater credit,
Yeah.
but it doesn't quite get the bite that we want here. What has been the mechanism or the conduit for convincing developers to start implementing GSI in
North
areas
Carolina?
that you work?
The main reason we have a lot of practices that are vegetated is because North Carolina is parts of North Carolina, very strict nitrogen removal requirements. And vegetated systems just score a lot better for nitrogen removal. And the state of North Carolina says you can use anything you want here, all right, but you've got to get your nitrogen number down to 6 pounds per acre per year. And bioretention cells and constructed wetlands specifically do very well relative to their peers of like sand filters or wet ponds for nutrient removal. So NC State, for example, is in one of those nutrient sensitive watersheds. We have about 150, 160 stormwater control measures on campus, and about 70 of them, almost half, are bioretention cells. And so if you take a look, and we have, and so, so there's one, that is the major reason that we have the more innovative vegetative stuff, is that we are really trying to get rid of nitrogen. There are some others as well, like watershed protection. They have, watershed protection is the main one. And so the developer sees a nice piece of property there and wants to use it. The jurisdiction, the governing authority is like, you got to do more than just the minimum if you're going to please us. And to do that, we're going to use a number of practices that we would throw under the green infrastructure umbrella. And the last one is, in certain parts of the state, we do see some developers want to have a lead, they want to market lead, all right? Or there are a couple like sustainable sites initiatives, they want to market themselves as a green development. And in those cases, they are using they're using the more innovative style of practices. But usually it's because a regulatory authority says either you have to keep your nitrogen, the main reason nitrogen, I can just shut it at that. Nitrogen is the main reason.
Okay, join me in thanking Bill for a very and like us on Facebook, follow us on Twitter at OSU CURA, and join our email list at cura.osu.edu. We do these types of events every semester, so this is the end of our spring 2018 events. Next year we'll have 3 events every semester on different themes related to cities in the world, and Columbus especially. So please follow us and join us next year. Have a good summer, everyone.
Take a brownie on your way out.
And take a brownie on the way out. Yeah.